Hi there, I'm Mike Glass with Orion Technical Solutions. Today I'm going to discuss a topic that I've been seeing a lot of lately on LinkedIn. The debate or the questions about using structured text versus ladder logic or function block diagram or other languages. Figured I'd add my 2 cents and my experience on that. There's going to be more and more desire to use structured text, I believe, because of the fact that I can literally take a standard, uh, you know, spec for how someone wants a program written, pump it into Claude or any number of AIs, and say, give me the structured text for this, and I can literally copy that in. I can copy it, paste it, and you know, it's like what you get a lot of with AI. It might work. Um, Also, there are some real cool things about structured text. So I'm not going to naysay that. There are situations where structured text is fantastic, and I'll talk about a little bit of those. But most of the debate that I'm seeing is centered around the end user, uh, and I think it's safe to say the end user in nearly every situation is going to have somebody at the plant who is not a seasoned programmer, or at least that's not their main job. They're not an integrator. Their job is to work on 5,000 things, one of which is the PLC that we're discussing right now. So they may not be super savvy at programming, and they may not have much experience even with structured text. But even if they are great at structured text, they've written Java they've written in all kinds of standard text type languages. There's still some pitfalls to structured text, and I'm going to show one of those is basically when you're looking at logic. So I've got some logic right now connected to a PLC. This is just some logic I was using in a previous blog, and I just pulled it up. Wanted something small and simple to see. So if I'm looking at this logic, when the high level float switch goes high, notice the power flow, these green lines. This green lines on the rails tell you that the logic is scanning and so forth, basically. It says, yeah, this logic's active, which is a great clue. But these conditions, if you will, this examine on instruction, or examine if closed, depending which wording you want to use. This examine on instruction, when that float switch closes, which in this case means above 80 inches, I get a green here. The power flow is green. That says I'm satisfied. Well, that's going to cause whatever output you have to be enabled or activated. In this case, it's a latch, which some of the comments are surely going to be, hey, it's a bad way to program it. It is. That's why I show it, because I want people to see the bad, not just the good. But anyway, so now I've got this high level alarm bit latched, but I see that it's latched because it's green. And I see that it's green on both because that's how it displays. It shows the status. It doesn't say it's unlatching, it says it's on. Well, if I were to push, now that the high level float switch is down, if I were to push the reset button, which I have wired up to input 11, I see I'm pushing the button. This examine on instruction turns green, says I'm satisfied, which unlatches the high level alarm bit as long as the float switch is low. Again, this logic is laid out goofy to show something else, but the point is you can see what's going on here. So now if input 4 is on, I have this little teeny fan that you can hear if I put it on the microwave or on the microphone. This little teeny fan is running. Well, that's because I meet the conditions, but let's say I turn input 4 off. Well, now I don't meet the conditions. Or let's say that the high level float switch goes high. Well, guess what? I don't meet the conditions because I have a high level alarm bit, and that's one of the 2 requirements. So even if I turn input 4 on, but high level alarm bit is latched, well, I'm not going to get the pump. I can see all that based on the alarm flow. And there might be, in many actual control programs, there might be 10 or 20 of these conditions, permissives, if you will, in front of a certain output. And that's normal. That's ladder logic. That's what it's replacing old relay systems. What I'm going to do is in a second, I'm going to show you what that looks like if I try to do this in structured text. So I have a little structured text program here that I will open. It does the exact same thing. It's the same code, and I Clauded it. I basically said, "Hey, Claude, convert this to structured text for me." So I'm just going to open this up. And just download it. And basically this structured text is doing the same thing, and we're going to see how it's different from a troubleshooter perspective. When I'm teaching programming classes, I always teach. I teach two roles. I call it, they're kind of like the two commandments. One is it has to be able to be troubleshot by the people that are going to troubleshoot it. Number two is it has to be able to be modified in the future. It doesn't. You don't want to end up with a bunch of spaghetti code that somebody's not going to be able to change. So basically, in this case, commandment number one is sort of broken. This is what you come up with. Is the same program when I just did the AI conversion. It took it 15 seconds to do the whole process. But I'm going to turn input 4 on and off. Well, you don't see anything happening really. Well, you can if you right click and then you go to the monitor tab and then you come back, but you don't see it all happening together. And then the float switch, it's open, it's closed, it's open, and you see nothing. So while this program might work functionally, it doesn't have the tools for troubleshooting. And I think one of the misconceptions sometimes that happens is, I hope I don't offend any structured text people. If you're a structured text person and you have 5 or 10 years in industry doing troubleshooting, I'll bet you money you agree with me. Structured text, people who learn structured text IT type programming and then just kind of land in the automation world sometimes at first don't fully recognize that the troubleshooting is the most important part. In the IT world, you don't have inputs and outputs that fail. In the industrial world, automation world, we do. When they write a program, it does its thing. Once you debug it, it's going to do that. There might be hiccups if somebody loads the wrong subdriver or whatever, but you don't have little inputs like this float switch failing. Likewise, you don't have a contactor that doesn't doesn't close or doesn't operate properly. The aux contacts don't close or so forth. In the industrial world, we have a lot of that. And so the systems, these relay ladder logic programming is meant to replace really is the old ladder relay ladders with tons and tons of relay contacts. It's basically the discrete on-off go type stuff with timers, and you can have counters, you can have all that kind of stuff. But it's that typical type of equipment that you would be able to see everything on that ladder logic rung and go, yeah, I see what's going on here. Likewise, function block. There's a lot of machines that you wouldn't want to program in function block because it doesn't make sense. A bunch of conveyors trying to start a cascaded conveyor at like a sorting plant. Probably function block's not your thing. But if you're trying to run some fairly complex feed-forward process control with some bias settings and some kind of advanced control strategies, you're going to want to see all those analogs and how they interact on the lines in between those function blocks. Function block is the way to do that. Don't do that in ladder, and definitely don't do that in structured text. Likewise, if you're trying to do some Modbus mapping, you're trying to arrange data, you got to do swap bytes and a bunch of weird, hard stuff. You're trying to package data for messaging, packing and unpacking data. You're trying to do some calculations or even some analytical type stuff or some statistics, high level math, and it's kind of in the back. It's not really controlling the logic. Structured text is the way to go, and that's the reason they have all these different languages. It's what I'm seeing on Instagram is people are acting like it's a choice. You pick one and stick with it. Uh, it's not that. It's you in a control logics program, for instance, a really well written program is likely to have three or more types of logic for different things. A good program might have that structured text to do some of the analytics, some of the statistical stuff, keep a track of run times, number of starts, balancing your motor run times, all that kind of stuff. That might be there. Uh, and messaging, setting up some messages, communicating protocols, all this kind of stuff. You might have ladder logic to control the actual discrete type machines, the go, no go, the starts and stops and all that. And then you might have a couple of PID loops that are interacting or somehow tied together, ratio control or something like that, cascade maybe. And you have that shown in function block. It can do all three. All of them can. Siemens, Rockwell, they can all do all of them. And that's for a reason. And even a lot of times, I don't have as much experience with it, but sequential function chart type machines, if you're doing a lot of stuff, that is very handy. And I've used it a few times, not a whole lot, but I have seen it used quite well. I just didn't get to dig into it, didn't need to. But there's language for each different scenario. It's not one, pick one, what are you best at? And I would say anyone that, if an integrator tries to tell you that, you definitely need to go with structured text only, uh, make them explain why and ask them these questions about the troubleshooting. Are we going to be troubleshooting this, or are we going to have to call you to troubleshoot it? Sometimes they can set up on your HMIs. I've done this for customers where they did not have anyone who was at a level to troubleshoot well, even ladder logic, mostly just operator type plants, right, where there's kind of an operator tech. And I've set up on the HMI where I basically set the equivalent of those permissive trees. But you have to realize that that's a translation. So the little scenario I just had where that logic itself is kind of flawed depending on the scan cycle, if you catch that, that HMI would probably not factor that in, and it would give misleading results. There's nothing like looking at the real logic to kind of figure some of these things out. So I promised myself I'd keep this one kind of short. Hopefully that explains the difference, and you can see the fundamental difference that I just can't see anything happening. I can't see what's going on in structured text the way that I can in ladder logic or in function block if you're talking about a bunch of analogs and so forth. So hopefully that helps explain why each language has its uses and get you a little further along. Feel free to add comments, give me input. I'm learning every day when I do these blogs. There's a bunch of smart people out there, so I'm sure I'll learn some stuff on this too. So enjoy and good luck.